So here in 9.4, we're doing graphing parabolas in vertex form, which is what I just showed you earlier. So we're doing vertex form. Go ahead and highlight that or underline that. So what you're going to do is sketch the graph of y equals x squared. Y equals x squared. How are we going to do that? Well, we're going to fill in x. We are going to substitute in x a number. So let's go ahead and do the first one together. So I have y equals x squared. So I'm trying to find what my y is. So if I were to plug in that -3, so remember we are going to substitute in that -3 for x. We're going to use parentheses first of all, whenever you sub in a number. And we have -3 squared. What is -3 squared? Yes, it is 9, positive 9. Then we'll do the next one, -2 squared. And then we have -1 squared. I'm just going to go all the way down and write all of, substitute in these x's, these numbers for x. So what do we get here? So we have 9. Go ahead and just shout it out. -2 squared. 4. -1 squared. 0 squared. 1 squared. 2 squared. And 3 squared. Very good. Now let's go ahead and put those points on our axis over here, or our coordinate plane over here. So we have -3, 9. Just a little bigger here. -3, 9. And then we have 2, 4. Actually, -2, positive 4. Then I have -1, 1. And 0, 0. Now let's go ahead and do the positive x's. We have 1, 1, 2, 4, and 3, 9. So I don't know about you, but we could kind of see our parabola already taking shape here. So let's go ahead and connect those points. Remember, a parabola is round at the bottom, not pointy. That would be an absolute value. So we have our parabola here. Let's go ahead and move on to the next part. It says, note, every quadratic equation has this basic shape. So every quadratic equation is going to be in the shape of a parabola, which looks like a U. How do we know it's a quadratic equation? What is the clue in our equation that shows us it's going to be a quadratic or a parabola? The what? Go ahead. Okay, the basic shape of it is the parabola. But what is about this equation? Right, that 2 right there is going to tell us that it's a quadratic. That is our clue. So if you see that exponent of 2, you know it's a quadratic, and you can say, okay, I already know the shape of this is going to be a parabola. That's the basic shape. All right, so let's go to the next part. It says, number 1, how would the basic shape of the parabola change for y equals x squared plus 1? So we're looking at this plus 1. So we know x squared is that parabola, right? We just saw that right here. Up here, that's our parabola. Now plus 1, what does plus 1 mean about this? Does that mean we're going to go up or down 1 or left or right 1? Yes, we will shift up 1. So let's write that down. Shift up 1. Our parabola will shift up 1. And number 2, how would the basic shape of the parabola change for y equals x squared minus 1? Right, shift down 1. Very good. So it says right here, graph the following parabolas on the same set of axes right here, axes. So y equals x squared. So let's go ahead and do that. Y equals x squared, which we know it's here, right? We start at 0, 0, the origin, and then we go up 1 to the right 1 and to the left 1. And we can connect our 3 points. Okay, let's go ahead and do the next one. We have this plus 2. What does that plus 2 tell us to do? Up 2. So let's move that vertex up 2. There we go. So now that's our starting point. Then we go up 1, then to the right 1, to the left 1. Connect our 3 points. And last one, we have this minus 2. What does minus 2 tell us to do? Yes, down 2. So let's move our vertex. Starting at 0, 0, we go down 2. And then we can put our second points. So remember, a parabola, you must have at least 3 points graphed in order to draw the whole graph. Okay, let's go to the next page. Number 3. How would the basic shape of the parabola change for y equals? Now notice, this plus 1 is within the parentheses now. It's not on the outside. Yes, it would be left 1. Yep, some of you remember, right? We will put shift left 1. Number 4, how would the basic shape of the parabola change for y equals x minus 1?
Right 1.
Right, shift right 1. Shift right 1. Good. Now go ahead and graph the following parabolas on the same set of axes right here. So, y equals x squared. Of course, our vertex is on 0, 0. Then we go up 1 to the right and to the left 1. Connect those 3 points. And then we have this plus 2 in parentheses for the next parabola. So what does that plus 2 in parentheses tell us to do? Right, we will go to the left 2. So let's move our vertex from 0, 0 to the left 2 and put our next 2 points. And then there's a little typo on this last one. Go ahead and make that a minus. Should be a minus, not a plus. Okay, so we have x minus 2. What does that tell us to do? Left. Actually, is it left or right? Yes, right. Right 2. So we're going to start at 0, 0 and go to the right 2. And put our other 2 points and connect our 3 points. Okay, very good. Now let's put it all together. Graph each of the following without a calculator and without a table of values. So we're just going to use our transformations here. So we have this minus 1 at the end. What does this minus 1 tell us to do? Yes, down 1. And then what does this plus 2 tell us to do in parentheses? Yes, left 2. So we're going to start at 0, 0. So let's go ahead and start at 0, 0. We will go down 1 to the left 2. So let's go ahead and go down 1 to the left 2 and put our vertex. Okay, now we can, now how do we know to go up 1 over 1? Well, we are going to look at this number, which is our A, right in front of that parenthesis. Nothing is written here, but we know there's a 1 in front of it. It's an invisible 1 basically, which is like 1 over 1. So that tells us for our next point, we will go up 1. So follow my cursor. You go up 1, then to the right 1, to the left 1. So let's put our points here. Up 1, to the right 1, to the left 1. And then we can connect our points. Okay, letter B. Let's go ahead and do this one together. Plus 1 means what? Right, up 1. Sorry, let me fix my pen here. Okay, yes, so we go up 1. And then this minus 1 means what? Yes, right 1. So we're going to start at 0, 0, go up 1 to the right 1, and there's our vertex. Now for the next part, where do our next 2 points go? Well, we look in front of this parentheses at our A. We have 1 over 1, right? So we go up 1, to the right 1, to the left 1, connect our 3 points. Letter C. Go ahead and do that on your own, and we'll check right after. Don't forget to write down the transformations and then put your points on the graph. So write down up or down, left or right, and then put the points on the graph. Okay, let's go ahead and do C. We have this plus 3, which means what? Up 3. And this plus 2, which means left 2. So we will go up 3, left 2. Very good. And then we have our, what we call our quote slope, which is our A right there in front of that parenthesis. And that is 1 over 1. So we go up 1 over 1 to the right and then to the left. Connect those points. And you have your parabola. Now, this next part right here says, look at each graph. Now, is this a maximum or minimum value? And if so, what is that maximum or minimum value? So let's look at A up here. Notice we have this, looks like a valley, right? So it starts at the top, goes all the way to the bottom. So are we going to have a minimum here or a maximum? A minimum. So let's write minimum underneath it. So minimum, and what is our minimum here? -1. Yes, we're looking to see how low this graph goes, and it goes as low as -1. Yeah, so we're looking at the y-axis value here. Okay, let's go ahead and look at the next graph. Do we have a maximum or minimum here? Right, we have a minimum. A minimum of what? Of what? Yes, of 1. Very good. And letter C, do we have a minimum or maximum here? Well, look at C. Right, we have a minimum. And minimum of what? Right, minimum of 3. So it goes minimum of right here, which is at 3. So it's showing us how low it goes. Okay, next page. All right, now it says, how would the basic shape of the parabola change for y equals -x squared? So now we're working with this, y equals -x squared. So this negative right here is new to us. What does that negative in front of it mean? Okay, so it makes it negative. Well, that tells us it's basically going to reflect over the x-axis. That is the terminology we will use, is saying it reflects over the x-axis. Basically, it's going to flip your parabola to the other way. Normally, we see it like this, right? We usually see it like a valley. It goes like a U. However, now with a negative, it's going to flip it the other way to where it looks like a hill. So it's going to reflect. So let's see what this looks like on the graph. So it says sketch the graph of the parabola y equals negative x squared. So let's go ahead and sketch this. So where you're going to have your vertex at 0, 0. Normally, our next 2 points go right here, right? We would agree. Normally, they go right there. But because we have to reflect over the x-axis, we're going to go down here. Again, remember, this is your x-axis, right? So we're reflecting across. So instead of right here, we're going to put at -1, -1. Put our point there. And instead of 1, 1, we are going to reflect across the x-axis to 1, -1. And then we can connect those 3 points. And now we are reflected across the x-axis, or reflected over the x-axis. And this is your y equals negative x squared. Okay, so let's recap everything we just did. The vertex of a parabola is, and this is the equation here. Go ahead and highlight this. Now, you know all of this information. We're just going to go through each one because each one is represented by a letter. So it says if A, so we're starting right here in the beginning, if A is positive, the graph opens how? Right, it opens up. If A is negative, again, we're talking about this number in front of the parenthesis. If it is negative, it opens, yes, down, right? That's going to look like that. If H is positive, now we're talking about H. This is the number inside the parenthesis. If that H is positive, the graph is shifted where? Left. To the left. If AH is negative, then the graph shifts where? Right. To the right. Good. Now we're talking about K right here. If K is positive, the graph shifts where? Up. If K is negative, the graph shifts where? Down. Very good. Now it says going from vertex form to standard form. So let's reflect, what is standard form really quick? Remember, who remembers what standard form is?
A squared plus B squared B.
Huh? That's standard form for the standard form of a line. But what about standard form for our quadratic equation?
AX squared plus BX.
Yes.
Minus C.
AX squared plus BX, actually be plus C. Perfect. Okay, that is our standard form. So we're going to go from vertex form, which is what we just did up here. See this part that we highlighted, that I highlighted in green? This is our vertex form. How can we take our vertex form and take it into our standard form? So we are going to do some algebra. So let's go ahead and do that right here. It gives us the steps. So here is our vertex form right here. So this is our vertex form. And we are going to get this from vertex form, and we need to switch it to standard form. So let's go ahead and, let me move this over so you can see the whole screen. There we go. Number one, the first thing you will do is multiply out the squared term. So we're going to take this x minus 1 squared, that's right there, and let's multiply that out. How do we do that? Remember, we used FOIL, F-O-I-L. So our first terms, we multiply together. That's x squared. Our outer terms, sorry, that is not outer terms. Let's do our outer terms right here. X times -1, negative x. Our inner terms, -1 times x, which is negative x. -1 times -1, positive 1. Now we have to combine those together. So now I have x squared minus 2x plus 1. So that's the first step. The second step is multiply out the a value. So here's our a value. It's that number in front of the parenthesis. So you will take that 2 and put that in front of what we found in the step above. So 2 times this x squared minus 2x plus 1. Now remember, when you multiply out this 2 into this, you will distribute that 2 to every term in that parentheses. That's where a lot of error happens, is everyone does it to the first term, but they forget about the next 2 terms. So 2 times x squared is 2x squared. 2 times negative 2x is -4x. 2 times 1 is just 2. The third step is add the k term. So let's go ahead and get that k term, that plus 3, and add that there. Now we can combine our like terms and get our final answer. So we get 2x squared minus 4x. Then this 2 plus 3 is 5. So here is our final answer here. The 3, we went up here to our k, and we brought that k down here. Okay, so now we have some examples right below. For A, B, and C, we are going to do those 3 steps. We are going to convert from vertex form to standard form. So for A, the first step we do is what? Right, multiply out that parentheses. So we have our x minus 3 times x minus 3. And don't forget, you're using the FOIL method. That's your first terms, your outer terms, your inner terms, and your last terms. Then combine all of those like terms together. And then what's the next step here? We what? Right, we bring out that -2. Now, normally we would multiply by a. What is our a right here? It's a 1. So if I were to multiply this whole thing by 1, what am I going to end up with? The same thing, right? So I'm not necessarily skipping that step. It's just it's going to give me the same thing. So I don't have to rewrite it again, but that is the next step. What is the third step now? Huh? Right, bring down that k, which is that -2. And go ahead and combine your like terms. So we have our x squared minus 6x. And what do we get? 9 minus 2? Yes. Yes, 7. So again, we're going from vertex form to standard form. So this is your vertex form. And we're going to standard form. Okay, let's go ahead and do B together. What is the first step we do? FOIL, yes, we FOIL out that x plus 2 times x plus 2. So we have to multiply that out using the FOIL method. Let's go ahead and FOIL that. First terms, outer terms, inner terms, and last terms. So now we get x squared plus 4x plus 4. What is the next step?
Where do you get plus 4 from?
Because 2 times 2,
Oh,
the last terms are 2 times 2, so that's 4. Okay, what would be our next step? Right, bring down that 5. Now again, 1 is our a term, and if we were to multiply that, we would end up with the same thing. So we don't have to multiply that out. We already have it written. So we're not skipping steps again. We are just moving on because we know times 1 will give us the same thing. So let's bring down that 5, that plus 5. And our final answer should be x squared plus 4x. And what's the last part?
Plus 9.
Right, plus 9. Okay, let's look at C. We have all of our values are represented. So let's go ahead and do the first part. What's the first step? Right, FOIL out that x minus 1 times x minus 1. And what do we come out with? Should come out with something like this. There we go. That's the middle step. Okay, what is the second step?
Distribute.
no, multiply.
Yes, multiply and distribute here. So we bring down that 3, right? So let's distribute that 3 across. So we have 3x squared negative 6x plus 3. All right, so that's our second step. What is the third step?
Add the k value.
Right. So now we end up with 3x squared minus 6x minus 5. By the way, let's write this down again. Again, this is going from vertex form, that's your vertex form, to standard form. Okay, all right, let's go ahead and turn the page. Last page here. It says, let's really put it all together. Graph each of the following without a calculator and without a table of values. Then determine if it has a max or min and what the value is. Yes?
For the negative sign in front of the parentheses,
Yes.
is that where you just flip it, like basically?
Yep, reflect over x. Yeah, we're going to
It's
write
like
that down.
Putting the negative in front of the x, but like the parentheses in between them.
Yeah, so we're going to reflect that. So yeah, that's just telling us we will reflect that over the x-axis. So let's write this all down for number 1, or for letter A. So we have this minus 1 right here. What does that mean?
Down 1.
Down 1. Yep. Plus 2 means left 2 or right 2? Left 2. And then this negative tells us to reflect over x. So let's write this down. Reflect over x. Now it's important to write this down because on your test, it's going to ask you to say what transformations you made. Okay, so get used to writing it down because you're going to have to write this down on the test. Okay, so let's move our vertex down 1 to the left 2. There's our vertex. And then our points are to reflect over x. So we are going to, normally our next 2 points would go up right here, but it wants us to reflect over x, so we're actually going to take them down 1 over 1. And again, they're talking about our x value here, which right here usually we go up, but we're going to reflect them the opposite direction. And let's go ahead and connect our 3 points. And you have your parabola. Now, is there a maximum or minimum on this parabola?
Maximum.
There's a max, right? So max of what? Yes, of -1. Very good. There's that -1 right there. Okay, letter B. Let's write down the changes that we're going to make. Again, you need to write down the changes. Okay, so -1. What does -1 mean?
Right one.
Right one. And this negative means
Reflect.
reflect over x. So again, write down those transformations. So we're going to go to the right one. Normally we go up, right, and to the right and left, but since we're reflecting, we go down to the right and left, or left and right, either way direction.
Wait, what was the maximum on number 1?
It was -1.
Okay.
Okay, let me see if I can make this a little bit straighter. All right. So do I have a max or min here?
Max.
Max. And what is my max?
0.
Yes, max of 0. Actually, let me put max of 0. All right, great. Letter C. Again, let's write down those transformations. Don't do them in your head. So what is this +3?
Up 3.
Up 3. And then we have that negative, which means what? Reflect over x. Okay, so let's move our vertex up 3. And instead of going up, we're going to go down to the left and to the right. Let's go ahead and go to D. +3. What does this +3 tell us to do? Good. We go to the left 3. And then we can put our points. We just go up 1, right? To the right and left because it's positive. Connect our 3 points. Now, what is our max or min? What do we have here?
Minimum 0.
We have a minimum of 0. Yes. Min of 0. Letter E. We have this +2. What does that +2 tell us to do?
Up 2.
We go up 2. And then this +1 tells us left 1. That negative says reflect over x. Again, yes, you have to write that down. Reflect over x. So we're going to go up 2 to the left 1. Reflect over x. That means we go down. And does this have a max or a min, this parabola?
Max.
Great. Max of 2. Yes. Now let's go to F. I'm going to use a different color here. We have this +3, which is up 3. So let's move our vertex up 3. And then we have our just up 1 to the right 1 to the left 1, right? Because we just have that 1 in front of that x. Connect those. So do we have a max or min here?
Minimum.
Minimum
3.
of 3. Very good. G, we are almost done. The last 3. So we have -3, which means what?
Down 3.
Down 3. -2.
Right 2.
So let's go down 3 to the right 2. And it's positive in front. Our A is positive. So we go up. Let's connect our points, and we have our parabola. And what is our max or min? Good. Min of -3. Okay, let's go ahead and do the next one. H plus 4, what does that tell us to do? Good, minus 1. And this negative is, right, reflect where? Right, over x. So let's go up 4 to the right 1, and then we reflect, which means we go down. Good. And what is the max or min? What do we have here? Right, max of 4. Okay, last one. I. We have this minus 2, which tells us what, class? Right, down 2, plus 2, left 2. Very good. So we're going to go down 2 to the left 2. It's positive, so we go up. Our A is positive, I should say. And then we have our parabola. Let's go ahead and connect those. And does this have a max or min? Min of what? -2.